Florian, do you want to kick things off?
I'm showing a very, very brief demo about a Memray integration we built. So Memray is a memory profiler in Python that basically traces your Python code and shows you where your memory was allocated. This helps you figuring out why you are taking so much, or why your process is taking so much memory, maybe find memory leaks for you, this kind of thing. Can even break down native traces, so C code, C++ code, which is pretty exciting. I built an integration to Dask for this. This is pretty easy to use, and this is what I'm going to show now. So to just get started, I built a very simple Parquet data set. And how this basically works is there's an import diagnostics Memray, and this command Memray workers now dispatches this tracer on all of our workers, samples this, and what I get back is basically, once this is done, I will get back a ready-to-use HTML report about the memory usage. So this is now doing some computation, as you can see. This is just running locally for now. Will be done in a second, and then we will get this report. So that should be done now. We can see this is actually generating the report in the background. And when I look at demo, now I have something. I will not explain how this works, but this is basically super nice if you are interested in this kind of thing that shows you at this specific point that I selected these various calls, allocated memory, how much that was, etc. That's pretty nice. What's also nice is that this actually works, with native code. I'm running the same thing, but with a native traces on. I'm also running this on a remote cluster, so this is now using Coiled. So this works basically everywhere, doing the same thing, but on a remote cluster. Sorry, this is the wrong one. Just to have a little bit of Dask TV, this is already done. This generating the HTML report on the cluster because it actually needs the live interpreter to do its magic. And then I'll get back the final HTML reports, remote, open. And yeah, this looks now a little bit more messy because, there's Parquet, arrow, native traces. Not sure. This looks like a lot, but this has been actually very useful. I've been using this to profile also scheduler memory and other things. And yeah, it's very easy to use. Just use it as a context manager and the magic will be done.
Are you worried about confusion with Ray?
No, I am not worried about this. I mean, in terms of memory profiling, Memray is a kind of established name already. And if we are importing this from a diagnostics import, so I'm not super worried about this.
Okay. It's supposed to be pronounced Memray, yeah? Memory.
Memory, okay.
Yeah.
Then I will try to pronounce it differently next time, yeah.
Not so well-established name, I guess.
I typically read it. I'm not talking to folks.
Yeah, just kidding. Sure.
I actually have questions about like how Memray, or however one pronounces it, works. Like historically, memory profiling in Python has been challenging because like we allocate these Python objects which like happen to have pointers to some like remote C allocated thing. Yeah. It seems like Memray is aware of that. How is it aware of that? Like how does it work? Do we know?
Yeah, this is complex. I think there's a hook in CPython, or that they are hooking into the allocator. They're also printing this. So what I like about the reports, the reports actually tell you how to use them. So for instance, this one is telling me that I should be using a environment variable, Python malloc, which bypasses the CPython memory pooling. So they can actually get the actual genuine memory allocation to the system. That's the one thing. And I think this combined with a hook in CPython, this way they can actually trace the actual allocations. But you still get sometimes false positives if a library behind the scenes is actually pooling themselves. Today, I've been chasing down something in PyArrow. PyArrow is, for instance, using their own memory pool, so they decide themselves when they want to release or not. This can cause weird artifacts sometimes, yes.
Yeah, I saw in the trace there was like JE stuff. I assume that's JE malloc.
I guess so. I actually haven't looked into this thoroughly myself into this specific example, but yeah. Yeah, here this is the native trace. They're gmalloc, yeah. gmalloc. I think Arrow is using this by default.
Any
But
chance
yeah,
something like this could be useful for GPUs? I mean, if you're having problems with Arrow, then I'm sure. Well, that's only one of the many reasons it would be challenging with GPUs, but just curious what you think.
I have no idea about GPUs. This is, you should tell me. I've used this also, so I've recently debugged an XGBoost workload, which showed me actually pretty nice and reliable traces for this kind of thing. So I'm still exploring. The integration was pretty easy, and yeah. Any other questions?
Thanks for sharing, Warren. That's really cool to see. Could you send me the documentation link for that? And I'll make sure to include it in whenever we send out. Cool. Okay. Well, next up we have Matt.
Hey, everybody. I wanted to share two things that are on like a common theme. I've been interacting with like less sophisticated users recently, and I've been thinking about how to make things more palatable to less sophisticated folks. Everyone on this call is like really sharp, and there are people who like do not understand as much as we do. They're like really good at some other like science domain or some other economic domain, but not tech stuff. I'm trying to make things like more streamlined in different ways. So I've been more sensitive to that. I'll show you two different things, one of which I'm mostly going to steal Nat's work. So this is more of a coiled thing. I apologize, but we've been playing around with the onboarding flow. And so like I just kind of liked what we did. So when you like set up Coiled for the cloud, there's like a whole process one has to do to set up IAM roles and everything else like that. And Nat made a nice little CLI command, which just like does everything. And so it like presents you some information, which answers some common questions. You then press enter and it like sets everything up. It was like a nice use of rich, which I liked also. Or like presenting information in nice little boxes, there's little summaries. It feels like a well-architected information organization. So I kind of liked that. I was sort of thinking about sort of how to make this as simple as possible, as few choices as possible, as less option-y as possible. I think in general, Dask has had this sort of massive flexibility, which I think has been really powerful for it. And this is maybe like going against that a little bit. It's trying to actually point people towards a common path so we can target some less sophisticated users. This is an example of that. I also wanted to show off this quotas piece, which is kind of fun and is not specifically Dask specific. A lot of users have issues with quotas. Like the standard AWS quota gives you like 32 vCPUs by default, which is like not enough to run anything. So we had a bunch of problems with people who like needed to update their quotas. And so I think Nat or maybe David made this little CLI command, which is not related to Dask, not related to Coil. It just like submits the right quota request for you. So I can see the quotas that I've got. I've got 10,000 vCPUs. That's fine with me. Maybe I want more vCPUs for Spot. So I'm going to submit a request and then submits that request for me. And GPUs, I'm fine. I've got enough of all of those. But if I didn't, I could change them. And like, you know, in a day or something, these numbers will be different. So if you have folks who are using the cloud and want to change their quotas and find the AWS console to be sad, this is a fun way to handle it. No actual like coiled stuff is necessary here, just a general useful utility. Getting back to the idea of supporting users who are less sophisticated, there are a couple of issues that I wanted to point out. I raised a little while ago. I just wanted to like cause some conversation around them. The The first was maybe renaming futures to tasks. We use the term future because it's consistent with PEP 484, one of the PEPs, I forgot which one, which is a concurrent futures module, which I think like we love, but no one else actually knows about. And maybe the word task would be more familiar. So I want to bring that up. It's like a simple thing. It's dumb. It doesn't actually like affect any capability that we have, but like maybe it is easier for new people to understand. I also find that this API is somewhat odd for people. So I have an even stranger suggestion, which is to annotate functions kind of like Dask delayed, but to use the futures API. I think the futures API is like just sort of generally better than the delayed API. And so I went to like maximum magic and made like the Dask module itself a decorator, or like one could propose that. So anyway, I was sort of thinking a little bit about ways to make the Dask experience a little less technical. I thought that was an interesting sort of theme for us to think about a little bit, make it a little more approachable. So that was it. Again, the theme here is like consistent theme, 2 little demos. One is some proposed changes for API. So we're like doing calls rather than submits, and also maybe changing the name of future to task. And the other thing was just showing nice sort of well-presented things in sort of the user experience that require you to press like enter once rather than type in a bunch of things and be configurable. So that was it.
What questions do folks have?
I'm just wondering how you would find out what you think novice users expect things to be called. It's going to depend on all of their previous experience. You can look at what other libraries call things, but you'll never make everyone happy.
Yeah.
Is this a unit of work, or is this a thing you're waiting for? I suppose is the sort of difference that you're trying to make here.
Yeah, definitely. I think that getting this stuff is hard and subjective, and there's not a clear answer. I think the way that I try to answer these questions is just by talking to lots of users, and I see what terms like connect to people or don't connect to people. For example, like I've noticed people who are coming from the JavaScript land, like the word promise. Promise is like a thing that's used often in that space. I think a lot of like science people don't understand promises or futures. Those aren't really, not science people, like analysts. Promises or futures are both very technical terms. Like we get them, but like the word future means something totally different in a general English sense. And maybe task is a bit more close to what like a non-technical person would think of this word being. But I don't have like a rigorous way of determining exactly the correct word. This is just from like 1,000 conversations.
I do like the idea of focusing on less technical or knowledgeable users, but I do also worry about like overloading the term task here in a way that's confusing to me. But I do.
Yeah, agreed. We use it internally quite a lot, right?
But that's the thing. Who among the users cares about what terms we use internally? Like they don't ever see that stuff.
Well, but if you launch one task and then you suddenly have a lot of tasks, called tasks, showing up on your dashboard, or in other documentation that refers to these things.
I don't think we used the word task in the dashboard to my knowledge, but we could also change that. But in general, again, like I think we've optimized a little bit for developers, which made sense for Dask's beginning, right? It was really aimed for other PyData developers. I think now as we sort of reach a bit more users and those users become less and less sophisticated, like the median user of a software project becomes less sophisticated as the project succeeds.
Sorry, I think I cut you off, Rick.
No, I think that I agree with both of you that it could be worked out. Just changing. There have been lots of discussion about even introducing a task object in distributed, right, and things like that. I'm just saying the word task is flying around a lot. I do agree with the general idea that we could simplify the user-facing API in a way that is consistent but different from the developer API, I think we could work it all out. So it's not like there's no blockers for me. I'm just saying, ooh, the word task is overloaded. Let's make sure we consider that. That's all.
My response is like, I consider that, but I don't actually weight it that heavily. I think the people here can deal with that complexity. I'd rather remove complexity from users and add complexity to developers if that trade-off is required.
Yeah, I'm okay with that. And then I was just saying the thing that you would want to consider is like, it does say, you know, if you the repr for an object might say how many tasks it's going to generate, which means something maybe different from what this idea of a task is. And so we just want to coordinate those kinds of things. That's all. But I agree with you.
Cool. I'm going to say, we want to put a pin in this discussion. We want to unpin it. We can at the end. So the next, unless there are any other questions for Matt about the CLI stuff. Cool. Okay. Jacob, if you're watching this recording, let us know if you have any questions or think this is useful. Hope you're having a fun time at your SciPy or whatever conference you're at this week. Okay. So let me go ahead and share my screen. I will go next. Cool. Okay. Hopefully you're seeing a notebook. If you're not, let me know. I'm going to bump the font size up a little bit. Hopefully the font size is big enough. If it's not, let me know. So I want to talk about some work I've been doing the last, I don't know, week or so. That is not directly related to Dask, but kind of it's on a library that integrates with Dask. So NASA has this Earth Data initiative for hosting a lot of their data sets on S3 in AWS. So this is useful for NASA researchers, people who are affiliated with the NASA or not, just general researchers or people out there who want to look at NASA data. This is lots of satellite images and other sensing data that's sort of publicly accessible. Actually accessing this data though, so this is publicly accessible. I'm not a NASA affiliate at all, but I can access this data because I went in and gave them my email address and they gave me like a little token, and I can now access the data with that API token. However, for a lot of researchers who are sort of less familiar with software, they're really good at doing science and less good at doing software engineering. It can be difficult to access this data. You have to, you have to get this token, you have to know how to do HTTP requests, you have to get temporary credentials to then access the data, and then actually finding the data is complicated as well. So some NASA software engineers have, so this is, to be clear, not my work. This is folks from like Luis and other developers have put this library together, Earthaccess, to help streamline this whole process to actually accessing this data from NASA. So what I'm going to do is talk a little bit about Earthaccess, and it actually integrates nicely with the PyData stack. And I'm going to talk about some ongoing work right now to make some improvements to Earthaccess. Okay, so with that, so here I have a Coiled cluster on AWS. That's just because it's easy to spin up. This works with any Dask cluster. The only important point here is my cluster, the workers are in US West 2. This is where all the NASA data lives. So that's like the one sort of important point to take away from spinning up this cluster, is it's co-located with the data. So the first thing I can do is, again, this is more just like an Earthaccess tour, is use Earthaccess to authenticate my local machine. Here there's a few different ways you can do this. I have a netrc file with that little token that I got lying on my machine. Earthaccess finds that and reads this in and authenticates things. So there are two things that you can do with Earthaccess. One is search for data, and then one is actually open the data. So here I am using this search data method to find a particular data set I'm interested in. For researchers and things, people actually accessing this data, hopefully this name is meaningful. They have a data set in mind that they actually want to go off and open. There is some name for that data set. You can give that name to Earthaccess. That's pretty much all that's required here. There are some other common operations researchers like to do. They like to subset the data set. They don't actually want to look at the whole data set. They want to look in some particular date range. or they want to look in some particular longitude, latitude box. So here I'm not providing a bounding box, but I am providing some, time slice I'm interested in. And this is nice because if you look at the other code that predates Earthaccess, it's very complicated to actually do these requests here and this slicing. So yeah, another thing I'm not doing here is you can actually limit the number of things returned from this data set. I'm actually asking for the full entire data set here. So this is, almost 2,000 of these granule objects, which makes more sense to NASA people, I've learned. But for me, this is just basically a bunch of metadata for each file in this data set. I'm not limiting here, so I'm getting the full data set. This is actually taking a while. I'm surprised. It normally doesn't take this long for reference. I'm curious if there's any outages or anything like that. So while that's running, what this does is this gives you a bunch of granules or things that you can then basically pass to Xarray. So normally what I would do, and this works very well for smaller data sets, is take those results. Cool, okay, so I got them all. That took about 2 minutes. That is, for reference, that's about twice as long as I was expecting. I'm not going to run this cell. This cell works very well for small data sets. Earthaccess has this open function you can use to take these results that you get from looking for data sets and then actually open them up. And what this returns are basically FS-spec compatible file objects that you can then just pass to Xarray. And Xarray understands how to open these up. It will open up your data set and you can do all your normal Xarray computations that you might want to do as a researcher. I'm not going to run this because for this full data set, I actually don't know how long this takes. I keyboard interrupted after 20 minutes last time I tried to do this. This takes a really long time to open up for larger data sets. This data set is a netcdf data set, which means it doesn't have consolidated metadata. We have to go through and manually, peek at each of the files and open them up to actually construct this Xarray graph. And this can take a really long time. So I'm not going to run this. Instead, what I'm going to do is talk about some of the ongoing work that we're doing to make this faster, this graph construction process faster. So I'm working off a PR right now in Earthaccess. So this doesn't exist in the latest release yet, but we're working on adding a consolidate metadata method. So the problem here is I don't have some single file I can just quickly access. I have to go through and access all of the files individually when constructing my graph, and that's slow. Luckily, Martin, who's on the call, maintains this project called Kerchunk, which is meant basically for this purpose. Maybe does other things too, but like for my purposes, that is what Kerchunk is for. Is taking these data formats like netcdf, HDF5, other things too, TIFF, I think maybe GeoTIFFs and things like that, that don't have consolidated metadata, and basically doing a single pass over the data to construct a consolidated metadata file. So then later on, when you want to access this thing, you can just point to the consolidated file and it becomes very fast. You basically pay that sweep over the initial data set, you pay that cost once, and then you never have to pay it again. Now you can access this data very quickly in the future. Another nice thing about that is we can actually pay that cost in parallel. We can run that initial sweep over the data set on my cluster. I'm wondering if I didn't actually update the, let me go over here and get my dashboard. I'm curious if I'm not actually running. Yeah, okay, is it showing over here? Oh, it is, perfect, cool. So here I'm actually doing that sweep over this data set, and I'm going to construct this consolidated metadata file. I'm actually writing it out to some S3 JSON file here. And that's it. Basically, this is the extra step here to scale to large data sets, write out this consolidated metadata file. And print out in just a moment that it's done that, and then it's written it to S3. Yeah, so there's my file for this particular data set. Now when I can, instead of reading in from these Earthaccess results, I can now point Xarray to that metadata file. And that takes, instead of greater than 20 minutes, it takes a few seconds. And now I have my X-ray data set, and I can do normal looking X-ray things with it. And that's also fast. So anyways, that's what I wanted to show, kind of for folks who aren't aware, provide some visibility into Earthaccess for accessing NASA data. For those of you who also aren't aware of Kerchunk, Kerchunk is a thing that exists, and we're currently working on integrating the two together here in this consolidated metadata to make it easy for researchers to like scale their analyses up. So things are nice and snappy. Okay, yeah, that's pretty much it. And then yeah, I get my result at the end. What questions do you have, if any?
Yeah, I have a question about how you use Kerchunk here. It makes sense a lot, exactly what you're doing. Like, hey, we have metadata that's kind of scattered throughout the data set. It also, I'm also wondering, well, what if you don't actually want to write a consolidated metadata file, or you don't have write access, or you just know that you have a data set like this, but you want to use Kerchunk just to do the parallel read of all the metadata into local memory and just use that to speed up your graph construction. Is that possible?
Martin, who's on the call.
Yeah, I'm happy to field any Kerchunk questions. Yes, it's totally possible. You don't have to write a file. It's just well, it's JSON, right? So it's a dictionary. So you can just get that dictionary. The API here, I don't know if that allows that, but Kerchunk certainly does.
Yeah, cool.
Does that have to
And
be
you
accessible in all the workers, Martin? That JSON file somehow? Like, can I say? So I get the consolidated JSON thing. I could not. All this is doing is that plus writing to a file. Can I pass that JSON blob here, and that just works?
Yes, but I think it would be copied to all the workers. So there'll be a serialization cost, I think.
Cool. Good question, Rick. Good to know, Martin. Thank you. Rick, does that answer your question?
Yeah, that makes sense. Thanks.
Any other questions?
Do you have any contact with the Tom's people, Tom Augsburger at Microsoft, does the Big Earth data or whatever it's called, the planetary computer stuff? So they have, I assume, somewhat similar data sets. So some of that will be NASA, actually, thinking about it. They have some Kerchunk based stuff, and they have quite an extensive library for interfacing with them, but I don't really know the details. It might be interesting to compare.
Yeah, maybe I'll reach out to Tom. That's a good point, Martin. Thanks for bringing that.
Is this actually being funded and run by NASA, and you're helping out, or was this your effort, or how? I guess Earthaccess is theirs, and
yes.
Yeah, go on. Sorry.
Earthaccess is not. I'm kudos Luis and company for their work there. So yeah, Earthaccess is not a Coiled thing. It's a NASA thing. Yeah, they're employed as software engineers at NASA, is my understanding. Thanks, Lauren, for presenting. Maybe you're already on vacation. I hope you are at this point. You're not on the call. Very good. If you're watching this recording, Florian, have fun on vacation. Thanks, Matt, for the demo. Okay, if not, then thanks everyone for coming, and I'll see you next month.